Hello everyone and welcome to today's lecture. In this video, we will explore one of the most important components of computer networks, the transport layer, with a special focus on transmission control protocol. Okay, so by the end of this section, you will clearly understand how TCP ensures reliable communication across the network. So as we know, at this transport layer, we have two major protocol, transmission control protocol and UDP, that is user datagram protocol. So okay, TCP is a reliable connection oriented protocol. Okay, reliable and connection oriented protocol. Whereas this UDP is simple, fast, and unreliable. It is unreliable. Okay, so TCP is reliable protocol, but UDP is an unreliable protocol. But it is very simple and fast. Okay, so we will only focus on TCP right now. Okay, so we can see that TCP, for example, for short, it's called Transmission Control Protocol. It's a transport layer protocol, and it's designed to send the packets over the internet. Okay, all this thing we know, and establish a reliable and end-to-end. That means we know that transport layer has process-to-process connection or end-to-end connection, right? So TCP, as it is working on a transport layer, it also does the same thing. Okay, but it establishes all those things before sending any data. I'm coming to this point. Okay, don't worry. Now, next point is it is a connection oriented, reliable, and byte string. Okay, what is the meaning of connection oriented? So this means connection oriented means TCP first establish a connection. See, it will not directly send a packet to a receiver. Okay, it will first establish a connection. Okay, what is the establishment phase that we are going to see now? Okay, then transfers the data in a reliable manner. Reliable means even if the packet is lost, there will be acknowledgement and there will be retransmission. So it will ensure that a packet will be received correctly. Okay, so no packet loss will be there. Most of the packet would be received by TCP. Okay, so finally closes the connection smoothly. The first is establish a connection before sending, then transfer the data, okay, in a reliable manner, okay, ensuring the data will be perfectly received by the receiver, then finally close the connection. Okay, that's why it is called connection oriented, right? And one more thing, see, it's the thing is how it does is that when the TCP starts its connection, then it at the sender and receiver side. So when the sender wants to send a packet to a receiver, at that time uh, it will ask, or sender will ensure before sending a packet that at receiver side all the resources necessary for that particular packet is already reserved. That is why it is called connection oriented. So resources means buffer. What is resources which will be reserved is buffer, bandwidth, and CPU. Okay, all this thing will be reserved at the beginning also before sending the packet, and once it is reserved, okay, then sender will send the packet. Okay, that is why it is called connection oriented. So all the resources are first reserved, then it will send the packet to the receiver. So we can see one of the example which uses TCP is a payment apps, right? See, payment apps wants us high reliability. Okay, there should be no data loss in payment apps. Payment apps like Google Pay, okay, Google Pay, Phone Pay, right, like Paytm. So all this requires a high reliability. There will be no data loss. Okay, accuracy, order delivery. Okay, means there would no accuracy. If there would be no accuracy, then what will happen? Then whatever the payment you are sending, if there would be some problem, if you are sending a 10 rupees and there because of some corruption it appears to be 20 rupees, then it's a loss for you only, right? So those things should not happen. So that's why, so all those application which needs a high reliability, accuracy, order delivery means whatever the order you are sending a packet, in that order only you will receive it. Okay, so if you are sending P1, then after P2, P3, okay, then this order should be maintained in the receiver side also. Okay, it should receive P1, then P2, then P3. It should not receive first P2, then P1, then P3. No, this order should be maintained. So however the sender is sending, and the same order the receiver will receive the packet. Okay, then secure encrypted connection and acknowledgement. Okay, if any application, okay, need all these things, then that application will use a TCP connection. Okay, it will use TCP protocols, right? So most of the payment apps, they uses TCP for their data transfer. Fine. So since TCP is a connection oriented protocol, okay, so it must first establish a reliable connection before sending any data, and this connection is created using a process called three-way handshake process. Okay, three-way handshake. So we are going to see what is this three-way handshake. So why do we need a handshake, right? So before two devices can exchange data, both sides must agree to communicate, okay, and synchronize their sequence number and confirm that the sender and receiver are ready. Okay, then only they should send a packet. Okay, first they have to agree to communicate, synchronize their sequence number. See, what is this sequence number? For every byte we are going to put a sequence. See, in TCP, one thing is that TCP is a byte oriented protocol. Okay, it's a byte stream protocol. What do you mean by byte stream? Is for every byte going out of the sender, every byte which is going out of the sender, TCP will put a sequence number on that. Okay, which means consider the sender wants to send a data to a receiver. Okay, and this entire thing is a data. This entire thing is a data. Now, if sender wants to send this data to a receiver, that it doesn't mean that it will entirely send this entire data, this complete data, okay, the whole data to a receiver. No. What transport layer will do is it will cut into pieces. It will chop into pieces. This data will be cut into pieces, and each piece is called a segment. Can you see? Segment 1, segment 2, segment 3. So the data will be cut into pieces, and each piece we are calling it as a segment, right? Or inside this segment there would be some piece of data, right? Okay, so what TCP will do is TCP will club all those 8 bits data, okay, all those 8 bits data into a byte, okay, and for each byte it will give a sequence number. For each byte it will give a sequence number, that is 0, 1, 2, 3, 4, 5. That's why TCP is called byte stream protocol. Getting it? Because for each byte going out from the sender, TCP will put a sequence number on each byte. Okay, so it will collect all those bytes, and it will put the sequence number. So each byte going out of the sender, TCP will put a sequence number. So each byte will be counted here, not bit. Remember this way. I am not putting a sequence number to the bit for each bit. I am putting a sequence number to the sequence on each byte. That's why it is called byte stream protocol. Okay. So in any connection oriented protocol like TCP, we have to establish a connection first. Okay, that is connection establishment, then transfer the data, and after that connection termination. Okay, then after that you terminate the connection. So for connection establishment, we have a process called three-way handshake, okay, which we are going to see right now. Right.